Hi, everybody. Welcome. So these two videos for these two parts are actually part of PowerPoints that are pretty hefty. So I'm breaking these into parts that are a bit more digestible. This video is going to cover the 6 basic operations of relational algebra calculus that we'll be using as part of our SQL code. And again, this is more theoretical. I won't go too crazy into the mathematical theorems and trying to prove and stuff here. But essentially, I want you to understand the basic idea of what they are trying to show and kind of doing it in your head or on an examples here as we go through it. So we said in the previous week that we're using query language to understand our databases and get our information. And again, a query is essentially you ask to get data back from some source. There's a few languages that we can look at here. There's some pure languages that use the type of calculus. And essentially, this is what we'll be doing with SQL. But there's some syntactic sugar over SQL. So essentially, join is actually using some form of calculus behind the end to get our data back. Great. So for today's topic, we're going to be looking at the relational algebra and then take a look at tuple relational calculus 2. And essentially, relational algebra consists of a set of operators that take one or more relations as inputs and then produce a new relation as an output. This is composable, so we essentially state that there's a sequence of operations that is going to be defined for us. And then we can also use these with different types of languages as well. One more thing here, the output that we get from an expression in RA can also be an input for a different RA expression later on. So this might be similar to your functional programming languages that you might see earlier where a function takes in a function as well. So just keep that in mind. Cool. So there's going to be a few operators, and then when I'm going through the slides, I'm going to say the operators' names instead of the actual symbol of them. So essentially, but if you prefer the symbols as well, just let me know. But essentially, great. So we have 6 basic operators for relational algebra that we've been looking with. And we have unary operators, which is going to operate on one relation that we have. And then there's going to be binary operators. Remember, binary is 2. So that's going to tell us that there's 2 relations that we're working with our code. So we have a select and a project operation. Select is very similar to getting a query in for a table. Project, you can kind of think of it as view. We also have these binary operations. So a union between 2 sets, or excuse me, 2 relations is going to produce a new relation. We can look at the difference between these 2 relations that we have as well. And then our Cartesian product. There's an interesting guy here at the end called rename that we'll look at more. But again, if this is a little confusing in the theoretical domain, don't worry too much. Once we get into coding, I'll reference these as well, and it shouldn't be too bad. But as long as you have a basic understanding of what these are doing in the back end, you should be good to go. Cool. So later on, you'll be able to read these types of tables too. But if this looks a bit overwhelming, don't worry about it. But essentially, if we take a look back at our operations, what we're saying here is from our relation instructor, select the department name, which is the attribute, and see if it's equal to music. And you'll notice here that our select operation, which was unary, is only operating with one relation. We go back again, we see teaches, so we look at the year, teaches in 2009. This little operation here is going to be a join operation that we have. And then we're going to join this on a course, which is another relation later. Join whatever result of our expression here with this current expression. Join these 2, and then go back and project name and title that is part of that new relation that we were only able to get because of these operations here. Okay. So I didn't expect you to know how to read that right away, but in general, this is kind of what we're doing when we're coding in SQL, and this is kind of one way to visualize it as well. Okay, cool. So relational algebra is important because it's simple enough once you get the hang of it. It can be a bit intimidating at the start, especially with the new notations that are here. But the most important thing here, because you can get it down with practice, but it's widely used for query optimization, which is essentially what we're going for because we might be working with millions of rows of data and we want to make sure that our operations are on top of it. Cool. So throughout our presentation here, we're going to be looking at these different operations. So a select operation, for instance, and we're also going to be looking at the example, so each of these have their own example, and you're going to be given a relation table. Remember, this is my big table with all my attributes as columns. We're going to check what the output is there. We're going to try to ask, okay, what did we do to this relation to project this output here? Okay. So the select operation is useful for filtering out a subset of tuples in a relation of R, and this is the notation that we get here. The P that's lower on top of the R, so we're saying select the relation R. The P that's below it is a selection predicate. The definition is here. I won't get too far into it, but essentially the P can be considered and or not. So P is going to be a formula in propositional calculus with these terms, and each term is one of an attribute of and another attribute or a constant here, right? So we could see here, I'm going to have my attribute OP of another attribute or a constant. And you can consider attributes as something that you type in manually here or as part of your existing relation. The OP that you have here is going to consist of an equal signs, not equal to, greater than or equal to, less than or equal to, okay? So you can kind of think of this as well when you're looking at your if statements and entering into conditional flow. This is where this comes in for our kind of query languages, okay? Cool. So when we actually look at our selection operation, the answers to these that we have are going to be given through the book and the slides that that Dr. Lee put together as well. But again, there's more than one ways to create these types of queries, but I'm just going to show you the ones that we are provided. But essentially, if we take a look at our relation R, we could see that the projection or the output of it has alpha and beta here for A, alpha and beta here for B as well. And we notice that we can't really do too much with those two because both of them are similar here. We notice in the C column that we have a 1 and a 23, and in the D column, we're only getting a 7 and a 10. Okay, so one way that we could actually write this is go ahead and select everything from our relation R, again, predicate A, and this is my predicate that we have, right? So I'm going to say select from my relation R where A is equal to B and D greater than 6, okay? So A is going to be equal to B. We see here A and B are equal in this scenario here. And now, what is my D value? That's greater than 6, so I'm going to bring them into here. I'm going to say A is equal to B, okay? B and A are equal here. I jumped out for the second one, right? Because they're not equal in this scenario. Now, I'm kind of ignoring C here because it's not so much in our argument, but you could try to filter in C in a different select operation if you'd like. But we see here that tree is provided in our D. Now, if we go back down here, we notice that, we notice that the tree is not provided for us. So we're not going to put in that attribute. And we'll see here that we have A is equal to B. Skip over to C, we're not using it right now, but we have a 10 over here in our D, and that's greater than 6. So I go ahead and put it down, okay? So essentially, we're not pulling the 6 out of nowhere. We looked at what the output was here. We said, okay, well, D has to be greater than 6, and it looks like the A and B columns are going to be equal to, right? And again, our caret pointing up is what happens when we have the AND expression, right? So that's kind of your logic that we saw a bit earlier in propositional calculus. The OR in this scenario would create something else. So again, I want to reiterate that this is a selection operation of one type. So it's not necessarily across the board. You might be able to get this result differently, but this is one way we could do it. Cool. How about we look at selection operations in an actual table here now? So we can see, do I have an instructor in a physics department? Well, what I could say is go ahead and select, do my selection operation on the relation of instructor, and then my predicates, my little underscore after select, is going to say department name is equal to physics. Let's see if something like that. Cool. So I say select from my relation instructor where the predicate department name is equal to physics is true. Okay. And this outputs, let's see, we have Einstein in physics. Do we have another physics here? Oh, there it is. Sorry. So we have another physics here with gold, and then it outputs this here for us. Okay. Now let's get a little fancier here. We could also put an AND this will change it there. So we say select from the relation instructor where department name is equal to physics and the caret probably instructor.salary is greater than 90K. Okay. Instructor.salary is a notation for the actual coding language, but we could see here that this is where it outputs a salary, and we get rid of gold because they have a salary under 90K. One more operation, structures in a physics or computer science operation, so we can get the or here. So we say predicate, department name is equal to physics, or department name is equal to computer science, select from the instructor table here. Okay. So, excuse me. Before we go into project, with this information that we're looking at, I don't want the calculus to be very overwhelming if it's a bit intimidating too. In general, when you're doing these SQL queries, it's going to be similar to conditional logic that you've had before, but you can have very complex select operations to make sure you're getting specific individuals there too. But again, it's all based behind this propositional and relational algebra that we've learned from before.